Hello students, so let's try to solve this problem. This problem is from IE Irodov, one of the great book of understanding the physics. And this is question number 1.60. In this problem, we have to just analyze what will the role of coefficient of friction and the use of Newton's law. So let me read this question. In this arrangement of the masses m0, m1 and m2 of bodies are equal. The masses of pulley and the threads are negligible and there is no friction in the pulley. Find the acceleration w which the body m0 come down. So this is body m0 which have to come down. And the tension of thread binding together the body m1 and m2. So we have to find what will be tension between m1 and m2, and it is also given that coefficient of friction between m1 and m2 is k. So this is the arrangement and we have to calculate all these things. So let's try to go straight forward to solving this problem. This is a wonderful problem. Let's see how we can solve it in a very efficient way such that we can use a minimum equation to get the solution. So let us try to go for this one. So what is this particular arrangement? Let me draw this figure. So this is my this is your horizontal surface. Here is a pulley and here is mass m1 and the mass m1 is attached to mass m2 and these had some friction and one mass is going to hang, that value is equal to m0. So first we have to calculate what will be acceleration of m0. Let's try to go for this. So we have to just go for free body diagram. So weight will be there. So this value is equal to m0 g. Let's say this tension is T1. So in this block there is again tension is T1. And here my tension in the block M1 is T2 and this one is T2. So, and if this block is going downward, then obviously the coefficient of the frictional force will towards in this direction towards right. So what we have, this is my coefficient of friction and this is the frictional force will be in this direction. This will be F1 and here this will be F2. Now look at this thing very carefully. When you will see the complete system, when you are going to see the complete system, what you will find this tension T1 and T2 is going to act as internal forces. So once it is going to act as internal forces, what we can do, we can just neglect the effect of this T1, T2 for this combined system. So what will be equation of motion for the combined system? We can just write, so m0 g is there and here is the frictional force is into this direction. So we have minus m1 g k and again for this one we have minus m2 g k because normal this will be mass m1g and this will be normal n1, this will be mass m2g, this will be normal. So this value is equal to something m1 m0 plus m1 plus m2 into w. W is the acceleration for which this is going to go downward. And you will find hence this length of this string is going to fix. So what will happen? The acceleration of each particle will remain same. So why we can write in this way. And what we have done, we have just assumed that this T2 and this T1 is just internal forces for combined system. So from there, what we can find the value of W. That value is equal to m2g minus m1 plus m2 g into k by m0 plus m1 plus m2. So this will be our first, acceleration of the m0. The acceleration of m0 is the actually acceleration of combined body. Now the second thing is very interesting. what we have to do, we have to find the value of T2. So once we are going to find the value of T2, we can just write the equation of motion for this particular particle. So this particular mass M2. So what will happen? T2 minus frictional force F2 is equal to M2 into W. So this will be the equation of motion for this particular block. You can just see for this particular block. Only horizontal force is T2 and in this direction we have frictional force. So we have this particular force. So this value is equal to T2 and minus F2 is equal to K, M2G is equal to M2 and we have already calculated this W. So this value is equal to M2G minus M1 plus M2 G into K by M0 plus M1 plus M2. And now from here we can easily find the value of K. So, value of T2. So from the value of T2 we can get as K M2G into we have, this value is equal to not M into, so this value is equal to plus we have M2 into this particular value. So that value is equal to M2G minus M1 plus M2 G into K and by we have M0 plus M1 plus M2. So what we will do, we will just multiply this thing into this side. So what will happen? So once we are going to multiply all this thing, then we have the value of T2. The value of T2 is equal to K M2G into M0 plus M1 plus M2 and we have plus M2 into this value is M2G minus M1 plus M2 G into K and here we have M0 plus M1 plus M2. And now you can see this look very clumsy, but a lot of thing is going to cancel out. What will happen? This Km2G into M1 M2. So here you can see that Km2G M1 M2. So this part is going to cancel out on both the part. And finally we can get the final result. So final result what we will get is all about your T2. So once you will calculate it, this T2 is equal to, you can get M2G and you have M0 1 plus K upon M0 plus M1 plus M2. So this value you have the tension. You can just easily calculate this particular thing. So you will get this particular value as your tension. So look at here. Lot of people, what they will do, they will separately solve for M1, they will separately solve for M2, then you will go for M0, and then you will reach at this particular point. But if we have taken this as a consideration, the combined system as a consideration, then these two forces are treated as internal forces and we can write this equation directly. So this is beauty of this part. And again, for T2, we can just try to write for this one. So students, you can just try to solve this question with yourself. Thank you.